All right, number 19, it says which cannot be used to prove that the lines M and N are parallel. So this is going to be similar to problem number 17. I'm looking at 1 and 5. Those are going to be alternate exterior angles. So I know if they're congruent, then that is going to mean that the lines are parallel. So that one does work, which means it's not the right answer because we're looking for cannot be used. 2 and 4, those are going to be corresponding. And if those corresponding angles are congruent, then the lines are parallel. So that's not going to work as far as the cannot prove. 4 and 5, if that's supplementary to 5, or 4 supplementary to 5, that's not going to tell me if the lines are parallel. That's just going to tell me if I have a linear pair there. So this one would not be used to determine if the lines are parallel. Now, if 4 and 7 are supplementary, that one could be used because 4 and 2 are corresponding, and 2 and 7 would be supplementary. And since 2 is the same as 4, if 4 and 7 are supplementary, then that also means that the lines are parallel. So for this one, C is the wrong choice, or the right choice, because it cannot be used to prove the lines are parallel. Number 20 says in the figure below, lines F and G intersect lines D and E. I know that D is perpendicular to F, and I know that angle 3 is congruent to angle 4. Which of the following statements must be true? All right, so if they're perpendicular, that means that these two angles are 90 degrees, which means all the way around actually is 90, which would imply, or it does mean that the measure of angle 3 is 90 degrees. So this is true. And because 3 is congruent to 4, that's going to tell you that E is perpendicular to F, which would also imply that D and E are parallel, but that's not one of my choices. So I know this can't be it. This doesn't work because I'm not told anything about F and G. I'm not told anything about G, actually. So that may or may not be true. D is perpendicular to E. That would also not be true. In fact, we would actually say that D is parallel to E. So that would not be true. The only answer that works is G. That's the only information that I can conclude based off of what was given. All right, number 21 says, given the points A, B, C, and D, what type of lines are they? Since my options say parallel and perpendicular, that means I'm going to have to look at the slopes of A, B, and C, D. So I know that it's rise over run, or change in y over change in x. So I'm going to do 5 minus a negative 1 over 1 minus a negative 2 for AB. All right, that's going to be 5 plus 1 over 1 plus 2, which is 6 over 3. And that's going to reduce to 2 over 1. If I look at the slope of line CD, same thing, I'm going to do 3 minus 1, or excuse me, that should be 5 minus 1. And then 3 minus 1, which becomes 4 over 2, which is also 2 over 1. Since they have the same slope, that means they're parallel. All right. And I know they're not vertical because the slopes are not undefined. I know it's not horizontal because the slopes are not 0. In order for them to be perpendicular, the slopes have to be opposite reciprocals. So if I had 2 over 1 on the first one, in order for them to be perpendicular, the other slope would have to come out to negative 1 over 2. And since that did not happen, I know the only answer is A. All right, for 25, it says what function represents the perpendicular bisector of the line containing these points in slope-intercept form. All right, to do this one, there's going to be kind of lots of steps, so I'm going to try to break it down for you. The first thing that I need to find is I'm going to need to find the midpoint of these two. So I'm going to take my x's, my negative 5 plus 10, divide by 2. For my y's, it's going to be 8 plus 2, divide by 2. So when I simplify that, my midpoint is going to be 5 over 2. And this one, 8 plus 2 is 10. 10 divided by 2 is just 5. So that's my midpoint. The next thing I need to find is the slope of this line. So the slope is going to be equal to 2 minus 8 over 10 minus a negative 5. That's going to be negative 6 over 15, which would reduce to a negative 2/5. Now, because it wants a perpendicular bisector, well, the bisector was why we needed the midpoint. Perpendicular means I need to find the slope, and then I want to change the sign and flip it. So since this is negative, the perpendicular slope is going to be 5/2. Now I want to plug these two into the point slope form, which is y minus y2 is equal to m x minus, should be x1 here. Okay, so I got y is going to be minus, I'm using my midpoint as my x1, y1, so it's going to be y minus 5 is equal to 5/2 x minus 5/2. So when I distribute, I get y minus 5 is equal to 5/2 x minus 25 over 4. Then I want to add 5 to both sides. Y is going to equal to 5/2 x minus 5/4. Okay, and it did say you wanted it in slope-intercept form, so that would be my right answer. Y equals 5/2 x minus 5 over 4.